Hello friends, myself Munmun Ghoshal, working as a data scientist and trainer, and I welcome you all in today's session on identifiers and variables in Python. So let's start with. So let's come to today's agenda. The agenda for today will be like identifiers, variables, data types in Python, and coding using Jupyter Notebook. Coming to the first topic of discussion is like Python identifiers. A Python identifier is a name used to identify a variable, a function, a class, module, or other object. An identifier starts with the letter capital A to Z or small a to Z or an underscore, followed by 0 or more letters, underscores, and digits 0 to 9. Python does not allow punctuation characters such as at the rate, dollar, and percentage with identifiers. So let's go deep into Python identifiers. So as we all know that Python is a case-sensitive programming languages. So here are some more naming conventions for Python identifiers. The class name starts with the uppercase letter. All the identifiers start with a lowercase letter. Starting with an identifier with a single leading underscore indicates that the identifier is a private. Starting an identifier with two leading underscores indicate that it is strongly private identifier. If the identifier also ends with two trailing underscores, the identifier is a language defined special name. So this is a short nutshell on the naming conventions for Python identifiers. So next comes the reserved words. So these are the words which are already reserved in the Python dictionary, so like assert, break, class, and, exec, not. So these are the words which we generally don't use for variable definition. So these are the words which are already stored in Python libraries. Next is variables. A variable is like a container that stores values that you can access or change. It is a way pointing to a memory location used by a program. One can use variables to instruct the computer to save or retrieve data to and from the memory location. Python differs significantly from other programming languages such as Java, C, C++. This we have already discussed in the previous session. Okay, so this is especially different when it comes to dealing with the variables. The other languages declares and binds a variable to a specific data type. This means that it can only store a unique data type. Hence, if a variable is of integer type, one can use only saved integers in that variable when running a program. This is not in the case of Python. Therefore, variables are nothing but the reserved memory locations to store the values. So Python variables do not need explicit declaration to reserve memory space. Let us consider some variable declarations, as the first one is x equals to 100. What does it mean? That means a memory location named x has been created, which is storing a value equals to 100, and this 100 is of integer data type. The second is like distance equals to 1000.0. So there is a decimal point that identifies that this is a floating point number, and this variable distance is being assigned a floating point number 1000.0. The third is like a variable named name, and the value assigned to it is a string character named John. So wherever we call the variable named name, it is storing a value that is equals to John, and that value is a string value. So strings are always given in quotes. So this is what like a single assignment to the variables. Now similarly, we have multiple assignments as well. For example, A equals to B equals to C equals to 1. What does it signify? This means all the three variables A, B and C are assigned to the same memory location and the value that all the variables holds is equal to 1. What if I like A, comma B, comma C equals to 1, comma 2.2, comma hello? In this case, we can assign multiple objects to multiple variables. What does it mean? It means that A is storing the value equals to 1, B is storing the value equals to 2.2, and C is storing a string value equals to hello. So this is how we can do the multiple assignment with the variables. I hope you are clear with identifiers and variables. Now, next is data types in Python. The basic data types in Python are numbers, boolean, string, list, tuples, sets, and dictionaries. So we all will be discussing these all data types in details. So different IDs which we will be using is Jupyter Notebook, Spider, PyCharm. So as of now, we will be using Jupyter Notebook for our executions. For that, we have to install Anaconda Navigator. The installation steps has been already covered in the previous session. So let's start our coding using Jupyter Notebook. So for that, you need to open your Anaconda Navigator and you have to launch the Jupyter Notebook. So it will open in the default browser. For me, the default browser is Google Chrome. So once I launch it, the home page opens as this one. And I can upload the files. I can open a new file as like file, new and Python 3. So your new window opens where you can write your own codes and execute them. So let us discuss Python variables again. So variables are the containers for storing data values. Unlike other programming languages, Python has no command for declaring a variable. A variable in Python is defined through assignment. So let us learn the following types of variables in Python. So they are integers, float, complex, numbers. So these are all numeric type. Then boolean, strings, list, tuples, sets, and dictionaries. Let us learn them one by one and execute them using Jupyter Notebook. The first on the list is integers. So what do you mean by integers? The integer literals are created by any number without a decimal or a complex component, like 1, 2, 3, 100, 200. So these all are integer values. So let us create an integer named, a variable named my integer, and I am storing a value equals to 1 into it. And in order to print it, I use a command that is like print function is used, and in that I'm passing the parameter my integer. Let's run this. So once I run this, what I'm getting? The value of my integer that is equals to 1. Okay. What if I want to check the data type of my integer? So for that, will be using the type command. So print type of my integer, and if I execute this, so it is giving the class int. So the my integer belongs to an integer data type now. So the next part is float. As already discussed, float will consist of decimal point. The float returns can be created by adding a decimal component to a number. So y equals to 1.0 or y equals to 11.0. So these are all floating point numbers. So what I'm doing, I'm assigning a floating point number to a variable named y. And then I'm printing the value of y. So if I execute this, my result will be 11.0. And if I again execute the type of y, that is a data type, the y is holding, that is equals to float. Coming to the third type, that is complex. Now, what are complex variables? The complex literals can be created by using the notation x plus yj. So where x is the real component and y is the imaginary component. So let me create a variable named complex underscore num, and I'm storing a value equals to 1.0 minus 2.0j. So this means this is a real part and this is the imaginary part of the complex number named complex underscore num. So if I print this value, what is the output? Like 1 minus 2j. So this exactly represents this format, x plus yj. Now to check what is the data type, again we'll be using the same command type, and if I execute this, so I will be getting what is the data type, that is equals to complex. What if I want to extract the real part separately and the imaginary part of the complex number separately? For that, what I am giving is like print command with complex underscore num, that is a variable name, dot real. That means what? The dot real will return you the real part of this complex number. Similarly, dot imag will return you the imaginary part of the complex number. Let us execute this. So the result is the first one is the real part, that is 1. So we can easily verify 1 is the real part, and the imaginary part is minus 2. So this is what we are getting here. So this is a quick introduction to like integers, floats, and complex numbers. Hope you have got it. So let's proceed to the next data type, that is Boolean. So Boolean is nothing but it consists of two values. One is true and one is false. Okay, so these true and false values are written without quotes, where T and F is in capital letters. Please make sure that Python is a case-sensitive language. Okay, so let me define a variable named boolean1 and assign a value equals to true. Let me define another variable as boolean2 and assign a value equals to false. And if I want to print those two values and execute this statement, what is our output? So the first statement prints the value of boolean1, that is true, and the second statement prints the value of boolean2, that is equals to false. Now again, to check the data type, we'll be using again the type function. So type of boolean1 and type of boolean2. Now if I use a print command along with it, so the output is coming out to be bool. So the boolean data types are given by bool. Okay, the fifth in the list was string. Now what is string? String is nothing but a sequence of characters. Strings are used to record the text information such as name. Okay, in Python, the strings acts as a sequence, which means Python tracks every element in a string as a sequence. This is one of the important features of Python language. String literals can be defined with single quotes, double quotes, and triple quotes. Okay. So how to create a string? In Python, as discussed, it is either single quotes, double quotes, or triple quotes are used to create a string variable. Let us try with some examples. So if I take a single word, that is hello, and insert it inside a single quote, that works fine and it will print hello. What if I want to write a sentence? Suppose my sentence is this is also a string and I'm writing it in single quotes and try to execute this. This also works fine. So that means the strings can be written inside single quotes. Let us try the same with double quotes. To execute a sentence which is written inside double quotes, so it also works fine. Okay, what if like my sentence is containing a quote inside and the sentence is like I'm using single quotes but will create an error. Let's check it creates an error or it goes fine. So if I execute this one, oh, I am having an error that is invalid syntax and it is pointing. Where is the error? Okay, for such kind of sentences which has single quotes into it, double quote does good. So what I can do, we have to be very careful with the quotes. We have to see how is our sentence. In this case, if I execute the same thing using double quotes, it should run fine. Yeah, it is running fine. Okay. So like if you quote with triple quotes, your string can span multiple lines. So triple quotes is generally used for mentioning a paragraph or multiple lines where we can have single quotes, double quotes. Okay. So if your paragraph is containing single quotes, double quotes, then triple quotes does good thing. So these are just the overview of the different data types. We will be studying the functions related to strings and detailed study in our later sessions. Let us consider the next point, a quick overview on lists. In Python, lists are an ordered collection of elements. Lists are mutable, that is, its values can be changed. Okay, so that means the elements inside a list can be changed. Lists are constructed with square brackets and commas separating every element in a list. Let us discuss list and construct a new list. Okay, let me create a variable named my underscore list and assign three values 1 to 3. So as we have seen, like lists are constructed with the help of square brackets. So elements will be specified inside square brackets and elements are separated by commas. So here 1, 2, 3. So this is nothing but a list of all integer values. If I execute this, so we are getting a list which is having three values, integers 1, 2 and 3. Similarly, we can create a list not only of single integers but of different data types as well. So we just created a list of integers, but list can actually hold different object types. For example, I'm creating a new variable named my underscore list and I am assigning values. The first value is a string, second is an integer, third is a floating point number and fourth is again a string. And if I print my list, then what happens? An entire list will be printed. We'll check it, but let's go with the indexing as well. So in Python, the starting index starts with 0. So A is assigned the index equals to 0, 23 index equals to 1, 100.232 has been given an index equals to 2, and the last string has been given an index equals to 3. So 0, 1, 2 and 3. Similarly, we can have an indexing from last as well. So this is having an index equals to -1, this is having index equals to -2, this is having index equals to -3 and so on. Okay, so let me find out, okay fine, if I print my list of 1 means output should be 23 in this case. My list of 3, that means what? 0, 1, 2, 3. So output should be this one. My list of -1. -1 means starting from this end. So this is again a last string. Let us try it out. If I execute this, the first print command is my list. So we are getting a list as it is. Next is like my list of 1. As expected, we are getting 23. Then my list of 3, that means 0, 1, 2, 3. We are getting the correct output. And the last one is -1. That means again we are getting the correct output. So I guess you are clear with the concept of strings now and the list. So in similar fashion, we'll go with the next part, that is tuples. In Python, tuples are similar to lists, but a very important factor is that they are immutable. That is, they cannot be modified, they cannot be changed. The tuples are used to present data that shouldn't be changed. The construction of tuples is with small brackets, with every element separated by commas wherein the arguments are passed within the small brackets. Okay, so let me define a simple tuple named t. The variable name is t and is holding three values 1, 2, 3. And if I print t, so we are getting a tuple which is enclosed in small brackets and elements are separated by commas. If I write type of t, that is returning what? A tuple. Similarly, you can try with list and strings as well. The next is like we can create a tuple with mixed data types as well, as we have seen in lists. So I'm passing three different data type elements into a tuple and I'm printing it. So this also goes well. Next overview is of sets. So what are sets? Sets are unordered collection of unique elements which can be constructed using set function. So let's go ahead and create a set to see how it works. So I'm creating an empty set named x. So I'm declaring a variable named x and using set function and storing it into x. So this means an empty set has been created. Now how can I add elements to a set? X.add, add is a function, and what element I want to add to it is 1. Okay, and I print this. So what output is expected? Curly braces and the value. So sets are given in curly braces. Okay, now this has to be made clear that it is unordered collection of unique elements. Since there are only one value, it works perfect. Let's try with adding 2 now. So execute this. Now set has been modified. So earlier it was 1 and now 2 has been added to the set x. What if I add 3 now? So it is having 3 unique values 1, 2 and 3. Now let's try with a repetition. So I am adding 2 again and let's see what is the output. So the output is the same as like 1, 2, 3. Since this 2 has been already present in this set, so it won't repeat it again and again. So this justifies that set is an ordered collection of unique elements. Okay. So this we have seen. However, we can cast a list with multiple repeat elements to a set and get to the unique elements. Let's try this. I'm creating a list, okay, named my list, and I'm storing some repeated values into it. And I am creating a set named x1 and passing my list into it. And let me print this. So what should be the output? It should contain only the unique characters or unique values. Okay, yes, it is containing all the unique values, that is 1, 2, 3, 4, 5 and 6. Okay, so this is what like introduction to sets. The last part is like introduction to dictionaries. So this is another data type in Python. So these dictionaries are nothing but hash tables in other programming languages. A dictionary consists of key and value pairs. In other words, dictionary consists of a key and then an associated value. That value can be almost any Python object. Okay? It may be an integer value, it may be a floating point value, it may be a string value, it may be a list even. Okay. So how to construct a dictionary? So let's see how we can construct a dictionary. So dictionaries are also given in curly braces, but there is a colon sign to classify between the key and the value. Okay, let me create my dict with some key value pairs. So let me add the key value as of now as string values. Okay, so the first key is key 1 and the value is value 1. The second key is key 2 and its corresponding value is value 2. And I print the dictionary. So what is the output? Output is like I am creating a dictionary with 2 sets of key and values. Now these values can be accessed with the help of the key passed. Okay. As compared to lists and strings, we were accessing the values with index numbers, but in dictionaries, they can be accessed with the help of key values. So if I print, my dict of key 2, so what it will print? It will print its corresponding value. Let us check. It is printing value 2. So this value 2 corresponds to what? Key 2. So this is how dictionaries are created. So that was a small introduction to different data types in Python. So it was like we started with integers, floats, complex numbers. So integers are like 1, 2, 3, 4. Float are like 1.1, 2.2, 3.3 kind of thing. Complex numbers are like real and imaginary part. Okay, so it is like 1 plus 2j. Boolean is true and false. String is collection of characters. List is an ordered collection of elements given in square brackets. Tuples are like ordered collection of elements, but they are immutable. The elements cannot be changed or modified. Sets is a unique collection of elements and given in curly braces. And dictionaries are the collection of elements in the form of key and values. So this was all about the basic idea of different data types of Python. Now we'll go with the last two topics of today's session, that is dynamic typing and strong typing. What does it mean? So in Python, while the value that the variable points to has a type, the variable itself has no strict type and its definition. You can reuse the same variable to point out to an object of a different type. It may be helpful to think of variables as labels associated with objects. So let me assume like x equals to 6 and I am printing x. Fine, fair enough. X is being given a value 6. So as of now, the x stores what kind of value? It is an integer type of value. I can remodify this as x equals to 14.2. So that means what? The same memory location x will now store a value equals to 14.2 that is of a floating point. Okay. So this is nothing but known as dynamic typing. Now let's come to strong typing. So while Python allows you to be very flexible with your types, you must still be aware of what those types are. Certain operations will require certain types of arguments. Let us assume. So what is this Python? So this is a string variable. Okay, what is this? This is an integer value. So if I use a plus sign, so plus either represents addition or it represents concatenation. If it is a string, it will concatenate, and if it is an integer, it will add. So if I execute this, what will happen? Yeah, it will throw you an error. And what is the error? Can only concatenate string, not into str. So like this has to be made a str, then it will concatenate. Okay, so let's execute this. So how we can represent it in terms of str? That is like in quotes, either single quote, double quote, or triple quote. It will take it as addition, that is like concatenation of two strings. Let me execute this. Fine. So like Python and 2020 gets concatenated into a single string. So this was all about dynamic typing and strong typing. So we have to take care of the data types as well. So coming back to my presentations, I guess like you are good enough to start with Jupyter Notebook now. So in the following sessions, we will be studying next with operators in Python. I guess this session was helpful to you. Thank you.